Plastics are tremendously valuable. They've brought a lot of good to humankind. Safety, efficiency, economy. So it's not a surprise that they grew like crazy. But the downside is that we began to see climate change and began to measure greenhouse gas emissions and carbon emissions and so forth. And then on the other end, we began to see what happens when all of this plastic ends up in the environment. Maintaining the functionality, maintaining all the good properties that we get from plastics, but doing it with less impact on both the front end and the end of life. And so that's been our focus since we started this company.
With over 300 million tons of plastic produced every year, disposal of these plastics is becoming an ever-increasing problem. One company in the heart of the country is working to solve that problem with biodegradable and compostable plastics. Nick Schmitz visits Green Dot Bioplastics.
Tell me a little bit about Green Dot Bioplastics. When was it started? What is sort of your mission?
Well, the company has, like many startup companies, gone through several phases. We started out originally as purely an R&D company. We were trying to develop and commercialize some technology to make what would be the world's first biodegradable rubber. The second phase of the company, we became a true manufacturing company along with R&D, and we had commercial products and began to sell them into the marketplace. And then the third phase of the company started in 2019 when we incorporated and began to pursue plastics for packaging, single-use disposable applications, all the kinds of things that you think of when you tear a wrapper open or open a box and immediately throw away the package. So that's the phase that the company is in now. We are launching those products. They're certified as biodegradable by international testing labs. We have patented the technology. And so really, after many years of working in that direction, this is sort of our coming out party. We're now doing all the things that we set out to do years ago when we founded the company.
Can you just sort of walk me through the difference between what we would think of as a traditional plastic, a petroleum-based plastic, and the sort of plastics you're developing here at Green Dot?
At the highest level, quite simply, bioplastics means that we're making a plastic, which is a polymer, and we're making it out of plant-based, renewable, sustainable resources instead of out of fossil carbon. So we're all aware of the issues with fossil fuels. The same issues remain when we make fossil chemicals and turn those into plastics.
What are some of the key differences between the bioplastics that you are producing here at Green Dot and what we would think of as more traditional plastics? Say a plastic bag that I get at the grocery store.
I mean, that's a great question. That's what our whole business and company and this whole bioplastics industry is about. So let's take the bag at the store, the shopping bag or whatever. It's made from a plastic called polyethylene that is turned into a film and then formed into a bag and printed with the grocery store logo. And you get your groceries and you take it home, and instantly that bag is trash, right? They say the average use of a shopping bag is 12 minutes, I think, something like that. So that polyethylene bag comes from fossil carbon. Through the refinery, it gets turned into ethylene or naphtha or something, and then converted into polyethylene. So it's quite carbon rich, if you will. A lot of fossil carbon is put into the atmosphere through extracting the oil, the refining process, turning it into polyethylene, making it into a film. We have released tons and tons of CO2 into the atmosphere. On the other end, after we're done with that bag in 12 minutes and we throw it away, it will sit in a landfill for tens of thousands or hundreds of thousands of years. If it doesn't make it to the landfill and it ends up on the beach or in a river or something like that, it can begin to mechanically degrade. And that's where microplastics, a lot of them come from. So now let's contrast that with a bag made from a bioplastic. We have a plastic that is partially or fully derived from a plant-based raw material. So therefore, we haven't put a bunch of carbon into the atmosphere. In fact, many bioplastics are carbon neutral, meaning that the plant absorbed as much carbon growing the plant is what was used to make the plastic. On the other end of the use, when we're done with that plastic bag, we can compost it and turn it back into organic material for the soil. And today there are any number of bioplastics that, especially the ones that we concentrate on here at Green Dot, that are also home compostable. So they're certified as being compostable in your own backyard or garden composting pile. They don't have to be collected and sent to an industrial composting site.
Mike, thank you so much for having us here. Tell me a little bit about this space. What goes on here?
So this is our product development lab. And in this space, what we do is we create new bioplastic formulations for various applications. And we're also able to do some testing on those materials to see how they compare to more traditional plastics. We create materials for things like packaging and injection moldable items like cutlery and things like that.
Okay, so a lot of the single-use items. And what's the process?
For our materials, we start by doing what we call compounding, where we're blending and creating alloys of different materials so that they have the right physical properties for whatever the application is. Those materials come out in the form of pellets. Those pellets are then taken by our customers, and it can be then remelted and processed into things like the sheet or film or cutlery or things like that.
So Mike, what are we looking at here?
So what we're doing right now is a small scale version of a process called blown film. And the material you're seeing run here is actually one of our biodegradable materials. So blown film is a process that's used to make plastic films, bags, things like that. And what's essentially happening here is our plastic is being melted and pushed through a die where the plastic comes out as a ring. The ring points up and air is injected into the middle of that ring so that the plastic is actually blown into a bubble. That's why we call it blown film. The material is then allowed to cool, and it is flattened into a sheet, which is actually a double layer sheet, and then can be collected on a roll. And that roll of material could be used again for bags, it could be used for mulch films or anything like that.
Okay. And so you're doing this on a small scale to sort of test your formulas to make sure that the end product will behave the way you envision it.
Yeah, that's correct. We also do this process to test how the material behaves during processing.
Okay.
So what are the proper temperatures, what are the proper speeds, and things like that, so that when we send the material to a real manufacturer, they'll have an idea of how to set their machine up to have the best chance of success.
So Mike, how do these plastics, the bioplastics you're developing here, stack up against more traditional petroleum-based plastics?
For the applications that we're targeting, these materials behave very similarly to the traditionally used materials. In their strength, their flexibility, they stack up quite well.
So I see we've got some cutlery here. And so is this spoon made out of the bioplastics?
Yes, it is.
I mean, I'm holding it, it feels like a plastic spoon. It doesn't feel any different, but you're saying that once I'm done with this, I throw this in my compost bin with my food scraps, and over time it breaks down.
Absolutely.
Wow,
Yep.
that's pretty remarkable. Versus if this were a petroleum-based spoon, how long would this sit in a landfill before it broke down?
Thousands of years.
Thousands of years. So you're talking a couple of months versus thousands of years.
Absolutely.
Wow,
Yep.
that's pretty remarkable.
Traditional plastics are still growing 2 or 3 times GDP. So we are still making, using, disposing of tremendous amount of traditional plastics. But bioplastics are growing about 10 times GDP. So a lot of the world gets it. A lot of the world understand that we can't keep doing the same thing we're doing. But what's happened recently that's driving it even faster is trying to do a much better job on the end of life story. And so about half of the trash that goes to a landfill is organic waste, food waste, yard waste, something that will break down if it's in the right environment, which a landfill is not really the right environment, but a composting facility is. But it's really hard to get that to the composting facility or even your backyard composting if everything goes into a traditional plastic bag. Or fast food restaurant can collect the food scraps, but if they use plastic straws, traditional plastic, and they use traditional plastic cutlery and the cup and the lid and all that goes together, then you just got a mess. It's not really compostable, and it's not recyclable because you've just made a mess, and so it ends up going to the landfill. But that's a case where bioplastics can enable all of this other organic waste to make it to the composting facility. Picture going into your favorite fast food restaurant, you drop your trash in the canister there, and the lids, the cups, the straws, the utensils, all of those things are compostable. The bag that holds it all is compostable, and inside is all of this food scraps, the drink that the kids knocked over on the French fries, and the bits of ketchup and whatnot on the paper liner. All of that can go together and go straight to the composting facility. And quite literally, we can take out half of all of the stuff that goes to a landfill today. As we speak, each day, more and more people are starting to figure this out. And let's face it, when you're standing in the grocery store aisle and, Junior's tugging on your shirt sleeves and you got to get home, you're probably not standing there thinking about all of these choices and options. So the goal of the industry is to eventually make this so that you don't have to think about it. Let us do the heavy lifting, and let us put products on the shelf that can satisfy all these demands. And it's a lot. I mean, but that is what we think about every day here at this company.
I, for one, am grateful that you are thinking about it, and thank you so much for inviting us in and letting us take a look around, and keep up the good work.